AI is taking over from fashion to art, from cooking to delivery services, from processing data to writing movie scripts, and now from robotics into engineering design. This creates a whole new branch of engineering. But does that mean that less design engineers are going to be needed? Or are engineers who just know how to extrude a part into existence going to become unemployed? Well, not really. To find out, watch this video. Hey guys, I'm MJ Sanga, your average engineer. AI has been a trend in science and technology. It has the ability to solve complex mathematical formulas, and now it can create images, generate code, and do so much more. And for the past few years, it has been used in engineering design software. Now, when it comes to design engineers have to go through a lot of trials and processes. This is because there are a lot of steps taken when designing a part or a product. We first state the problem. We need to first find out the problem in order to fix it. Take this design, for example. What is the main problem about the design that's causing it to fail? Focusing on one problem at a time is better than focusing on many issues at once. Next, we generate ideas. When working in a project, engineers are mostly teamed up with a diverse range of engineers in different engineering fields. This is a huge benefit as information can easily be found, and with diverse minds in the room, ideas can be generated quickly. Then we plan and select a solution. Writing down the strengths and weaknesses of each idea can help narrow down which idea is better. Variables such as cost, materials, how long it will take to design the product, and so much more are one of the key factors in deciding which idea will actually be picked. Next, we build the item. Based on the information, the skills and knowledge of the engineers put together, they design a CAD/CAM prototype and then perform simulations using CFD to see its performance. Then we evaluate based on the results obtained. Has the idea solved the problem? And what can we do to improve the solution? Lastly, we present the results. After redesigning, doing retrials, and constantly finding ways to improve the idea so that the problem can be fixed, the team can finally say, okay, create 2D designs and send it to the manufacturer to produce. Now, this is just a summary. In practice, engineers go through a whole lot of steps in order for the final result to be actually approved. However, there is a huge problem. It's a bit time-consuming. Engineers have deadlines, but what if there was a way to reduce the time taken by producing more parts and performing simulation at a faster rate? Well, that's where generative engineering comes in. Generative design is an iterative process that involves using a program that will generate a certain number of outputs that meet certain constraints and allows a designer to fine-tune the feasible region by selecting specific output or changing the input values, ranges, and distribution. In layman terms, it's a design process that allows design engineers to produce 3D parts by adding and changing constraints. This allows design engineers to produce 3D prototypes in a small amount of time. It's a very fast method of exploring design possibilities that are used in various design fields such as art, architecture, communication design, and product design. So then, how does generative design actually work? In order to further explain this, we first need a problem to solve. Let's say Johnny has 5 apples, so we need to calculate the mass of the sun.
Nani? Young man, where are you going?
I'm going
Young
home.
man, where are you?
I'm going home.
Just kidding. How about this one? We need to design a handle that can hold a board in place. Simple, right? Now that we have a problem, we need a CAD software. To help explain this further, we will use Creo parametric to show you how generative design is used to build a product. And if you're enjoying this video, hit the like button and subscribe to get up to date with my upcoming content. A subscribe could help me generate 1,000 subscribers. First, we open Creo parametric software. Then we click on New and select Part. You can name yours whatever name you want. I just selected to name it Part. Now we are going to design a simple part. This part will act as a constraint. This will tell the program the limited space it's allowed to use to generate the material. Then we're going to design separate parts inside the constraint we made earlier. After this, we make a datum plane, which will be needed for adding other constraints needed. Now we go to Applications and select Generative Design. On starting geometry, we select the first body we designed. This will show the program the needed area to work on. Then we select the preserved geometry. We will select the bodies we designed inside the main part. Now we select the excluded body. This body won't be added to the final part model. Then we add the needed variables such as fixed constraints and the needed loads available. Then we will go to design criteria. And in design criteria, we will add the material that the product needs to be and the design constraints. So the design constraints tell the program what to remove and how to remove it, and what volume of material should be added. We then click Optimize to check the final design. You can change the constraint values to see the different types of designs that can be made, and select Display Simulation to show how the part performs under certain loads. When satisfied, select Generate Design, and boom, we have our part. Now, as I was learning how to use generative design in Creo, I learned that it has so many advantages in engineering design. For starters, it gave me so many design options to choose from. When manually designing or editing a part or changing it or reverse engineering it, it can take a lot of time editing, changing the dimension, or adding something to it. But with generative design, it took less than 5 seconds. Another reason is that CFD was done during the generation process. It was searching for weak design areas and constantly changing the design until it found a better structure. Let's not forget that the product weight was optimized. There's no excess weight in the design. And the fact that it's an AI process, meaning that it can constantly learn over and over again from the mistakes and from the processes before. Generative design isn't here to actually take away design engineering jobs, but rather it's here to improve them. Efficiency is needed during engineering design, and accuracy is also important. And the fact that complex designs are manually hard to create, generative design makes it easy for design engineers over time. It's also an easy way to deal with complex structures, and AI improves. The more the AI improves and it understands how structures are designed, the more it becomes better at this process. Yes, it's true. Over the years, AI has taken many jobs away. However, it has also brought some jobs into the industry. And in order to get these jobs, obviously skills have to be learned, knowledge has to be gained, and other variables have to be taken into measurements into getting into this industry known as AI. This just shows that in order to get ahead of things, no matter what age you are, you still need to learn. And in this era, with the Internet of Things giving us the opportunity to gain knowledge, puts us at an advantage. Like the saying goes, what you do today defines your tomorrow. And if you want to learn more, you can watch my video on electric motors and any of my videos on this channel. Thanks for watching. If you like this video, please hit the like button and hit subscribe if you want to stay updated to my upcoming content. I'm aiming for 1,000 subscribers. Have a great week. God bless you.